I see. Alright. This is not included. Okay, that one is a trailing 0, but there is a decimal point. Alright, so that is 5. Alright, that's right. Yes, that's right. Okay, I think you clearly understood the rules in counting significant digits or significant figures. Are you ready for the rules in calculating with significant figures? Okay, so let's start with adding, addition, and subtraction with significant figures. Okay, so when adding or subtracting, we round the answer to the least number. So least number of decimal places. So you take note of this. Say for example, we're gonna add 1.457 plus 83.2. Okay. The first number has how many decimal places? 1, 2, 3, right? No, we're counting the decimal places, not the significant figure. Of course, it has 4 significant figure. This one has 3 decimal places, so you won't be confused. And the second number has 1 decimal place. Okay, if we're going to add them, we just add them like normally. Okay, we add them. This is just 756.48. But for rounding them off to the final answer, we round them off to the least number of decimal place. So the least number of decimal place is 1. So that means we round this off to approximately 84.7. All right, because 5 here, no, 6 here, the next number to 6 is 5, so you add 1 to 6. All right, how about when we subtract? Let's say we're given 0.0367 minus 0.004322. Okay, so we can, okay, let's count the decimal place first. This one has 4, and this one has 6. So that means the first number has the least. This one has the least. This number here. Okay, that means our answer will be rounded off to 4 decimal places. So let's subtract 7 minus 3, 4, 2, 3, 0, and 0. So our answer here will be rounded off to 4 decimal places. We don't include that, so our answer will be approximately 0.0324. All right? Okay, no questions in addition and subtraction with significant figures. You just take note, least number of decimal places. Now let's go to the multiplication and division. Okay, division with significant digits. Okay, when multiplying or dividing, we round the answer to the least number. Least number of significant digits or significant figures. Significant digits. Okay, for addition and subtraction, least number of decimal places, for multiplication and division, least number of significant digits for the final answer. All right, let's say we're given this one. We're gonna multiply these numbers. 4 point, yes, they're the same thing. Yeah, 0.00013. So let's count the significant figures of each of the numbers. The first one, okay, and the second, all right, so it has yeah, then let's multiply them. Can you multiply them? You give me the whole answer and then you round this off. Okay, so least number of significant digits, so it's 2. The answer should have 2 significant figures. Yeah, that's right. Yeah, you're fast. Okay, how about you're given 12.300 divided by 0.0230. Um, 4. Yeah, because the trailing zeros here are included, there is a decimal point. Yeah, that's right. Yeah, okay. So let's say we're given a times 10 to the b. Okay, a here is the value. Okay, absolute value of a should be less than 10 but greater than or equal to 1. So a number greater than or equal to 1 but less than 10, and this is the base 10, and this is an integer, the exponent that we're going to multiply the number to, or very small. Okay, so we are usually given the standard form, then we write that in scientific notation. So the first thing we do is we change the number to a decimal between 1 to 10. Let's say, for example, we're given this number 5,878,600. Okay, how do we read this? Million, billion, trillion, and 5. What's that? This is million, right? This is million. This is billion. So this is trillion. All right. Yeah. 5,878,600,000,000. All right. So yeah, how I wish I have this. I had this one. Yeah. Or even just here. I'll even if you just put 1 here. Yeah, like here, Dia. Even if I just have this 1 million, then I'll be very happy. Yeah. Why are you laughing? No, it's free to dream, right? Yeah. Who knows? Tomorrow I'll have that. Okay. Yeah. So the first thing we do is, okay, we're given that number. We change this number to a decimal between 1 to 10. So we have the last number 5, right? So we can change that to 5.878,600,000,000. All right. Okay, because the decimal was moved to the left. See, take note. Originally the decimal point here, which is implied, which is understood to be here, right at the end. So we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times. So that means we multiply the new number, this is our new number, by the power of 10, by 10 to the power of 12. Okay, to the left, that means the exponent of base 10 is positive. To the right, the exponent is negative. So that means this number becomes 5.8786 times 10 to the 12. Okay, so we don't need to write the trailing zeros. Yes, it can also be that. 5.8, 5.9. Yeah, it depends on, remember the significant figures, digits. Yeah, but this one, we are not multiplying or dividing or subtracting or adding. So it depends on the operation that you use. But in this case, we're only given a single number. So we need to write this one, the non-zero digits. Okay, and we can just leave the rest of the zeros. Okay, that one is for the whole number. What if, yes. Okay, so what if you're given this one? 0.0, oh no, not that one. Okay, so how do you write this in scientific notation? Okay, that's right. So this is from standard form to scientific notation. So how many? 1, 2, 3, 4, 5, 6. So 5.3, 3, 6, 7. This 6. You start from where you move the decimal point. The decimal point is here. So 1, 2, 3, 4, 5, 6. So you just move, yeah. So that is -6. No questions in transforming standard form to scientific notation? Okay, to the left, that is positive, the exponent of 10, and then to the right, that would be negative. Okay, now let's discuss how to transform or write scientific notation to standard form. Okay, can you go to the next page? Okay, scientific notation to standard form. Okay, what if you're given this number, 7.38 times 10 to the 9th? Okay, note here that the exponent is positive, so where should you move the decimal point? To the left. Yes, to the right. Okay, you write that in standard form. Yes, that's correct, because you move the decimal point to the right the same number of times as the exponent, so 9 times in this case. Okay, how about you're given 5.76 times 10 to the -8? Okay, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's right. Oh, okay, no questions in those. Now let's subtract, add and subtract within scientific notation. Okay. Addition. Am I too fast? because sometimes I seem like I'm in a hurry. I talk so fast. Okay. Addition and subtraction with scientific notation. So before adding or subtracting, we need to transform all of the powers of 10 to be the same. So what if we're given like 10 cubed and the other one is 10 to the fifth? You have to make sure the exponents of base 10 should be the same or equal, right? So what if we're given these numbers? So 3.4 times 10 to the fifth plus 9.7 times 10 to the sixth. How are we going to add them? So the first thing we do is we write the numbers to have the same power of 10. The first number has an exponent of 5. The second number has an exponent of 10. So maybe we can change this one, the first one, to make its exponent 6. Okay, so we can write this as we move the decimal point to the left. So this would become 0.34 times 10 to the 6th plus 9.7 times 10 to the 6th. And now we can add them up. So we just add these numbers, 0.34 plus 9.7, which is, what's this, 4, 10, 10.04. Okay, and then we rewrite in scientific notation. So this is just 10.04 times 10 to the 6, or to 10 to the 7. 1.00. Yes, that's right. Okay, the same with subtraction. So they have the same rules for addition and subtraction with scientific notation. Okay, what if you're given 49 times 100? Or no, 4.9 times 10 cubed. 4.9 times 10 cubed times 2.1 times 10 to the fifth. Okay, so you can rewrite this in standard form and then multiply them, or okay, yeah, that could also be, because this one, when you multiply terms with the same basis, you just add their exponents. Yes, that one is easier. That's all with the scientific notation, multiplying and division, addition and subtraction. Milli, centi, those are very useful. Like if I say micrometer, so that means meter times 10 to the negative 6, like kilometer. So that means meter times 10 to, what is kilo? 10 cube. Okay, and also when you're given word problems, there are some instructions that would ask you to round off your answers to the nearest tens, nearest tenths, hundreds, 10,000, thousands. So do you know the place value? All of those? Okay, so this is tens, hundreds, tenths, hundreds, thousands, 10,000s. Yeah, this is ones, tens. Like, say for example, I'm gonna ask you, can you round your answer to the nearest hundreds? Okay. Well, what is the... Okay, let me give you this one. 209.82. What is the place value of 8 in this number? Or what is the value of 8? Okay. Yeah, you should also familiarize yourself with those. Okay. We know that density is equal to mass over volume. Okay. What if you're given a volume? Let's say volume... okay, the mass is equal to 2.79 grams, and then your volume difference, change in volume, should be 8.34 milliliters minus 7.58 milliliters. Okay, this is volume 2, volume 1. So what is the density? And you apply the significant figures, the digits. All right. Then you solve for the density. That is mass over volume, 2.79 grams over 0.76 ml. Okay. What's the rule in division again? Yeah, for your final answer when you round it off. Okay. So what is the answer here? 2.79 grams divided by 0.76 milliliter. Okay, grams per milliliter. Yeah, that's correct. But then, okay. What's the rule in multiplication again and division? Least. Yes, that's right. Yes. Okay. Can you go to the next page? Okay, can you evaluate this? 4.184 times 100.620 times 25.27 minus 24.16. So evaluate this expression to the correct number of significant figures. You tell me how many significant figures does the answer have? Yes, you're right. This is the fewest. Alright, very good. Okay, how about this one? 9.6 times 100.65 over 8.321 plus 4.026. You write there 966.24. Then you divide by 8.321. Where did you get 0.11612? I got 11612. What did you do? You forgot the decimal point. Yeah, and then you add with this one. The last operation is addition. So what's the rule? Yes, decimal place. Least decimal place. 120. Yeah, only 120. Yeah, 120 point. 0. Yeah, but then it's only 3, right? So now it's confusing. So I think this is what we're supposed to do. We round off the multiplication and division first, based on the rules in multiplication and division. This one. So what's our answer here, supposedly? Oh yeah, because I was looking at this one. Okay, 2 significant figures. Yes, that one, 120. Or we made a mistake. Okay, we mixed up the multiplication and addition. Yeah. Okay, this is what we got. This is what you got, right? For adding. And the rule for addition and subtraction, the least decimal places. So you answered here 120.1. You were counting the significant figures. Its least decimal place is 3. So we should only leave 3 decimal places here. So it should be 120.147. Yeah, be careful not to mix them up. Okay, we're good. Okay, we're done with that. We discussed dimension analysis yesterday, but I'm gonna ask you to convert this. Can you please go to the next page? Okay, can you express this volume 1.250 liters in milliliters in cubic centimeters using conversion factors? So this is dimensional analysis. Can you convert 1.225 liters to ml and into cubic centimeters? Oh, what did you get the 10 negative 3? Okay, so this is, yeah, this is already in milliliters. Yeah, so the answer is only that one. That one. Yes, because you convert, see? This is how you convert that. So 1.250 liter times how many milliliters in 1 liter? That's 1000, right? So 1000. And then this cancels out, so you'll be left with the ml unit. So 1,250 times 1000, that is 150,123, right? Milliliters. And then you write that in scientific notation. 1, 2, 3, 4, 5, 6. Is that it? So 1 point, or for a while, 1 to 50 is not okay. So this is only 1,250 milliliters because I forgot this is a decimal point. Okay, and then when you convert that to, okay, can you convert that to cubic centimeters? This one, the 1.25 liter. This is how you're going to convert that. Let me change the color. Okay, so originally we're given 1.25 liters, right? And then how many cubic centimeters does 1 liter have? Is it the same as, yeah, 1 milliliter is equal to, yeah, 1000 milliliter is equal to 1000 cubic centimeters, right? Yeah, so we can multiply this by this conversion factor. 1 liter is to 1000 cubic centimeters, and then liter unit here cancels out. So what is 1000? 1.250 times 1000. Yeah, so it's the same. All right. Yeah, so you should take note of that, especially in stoichiometry or stoichiometry.